This video is going to be going through activity 4.7, cams in motion. This particular video is going to be addressing how to make the pear cam. There are other videos that will also address how to make the eccentric cam, the snail cam, and the hexagon cam. For this activity, you're going to also want to look at some of the other videos that are made for you already in PLTW. So if you log into my.pltw.org and you go to the course, you're going to be going to Unit 4 Pilot, then to Activity 4.7, and in the Resources tab, there are 3 different videos. One describing cams in motion, how you make, what the motion graphs look like, how they relate to the shape of the cam. The other one is about placing features, work features like work axes and work planes in your cam to help with the modeling. And the last one is how to assemble the automata to help to look at the motion and read and actually complete the activity. You'll also find in here the automata simulation zip file, which includes the box that you'll need in order to actually complete this activity. In this zip file, you'll find the axle, the box, the follower, and the guide, as well as the ruler. It's also shared with you guys in the Unit 4 Pilot under the Automata Simulation folder. In order to make the cam, the first thing that you want to do is start a new part file.
Becky Louder, if you are still in the building, I have a phone call for you. Please call 305. Becky Louder, please call 305.
Now, you can choose any surface that you want to draw on. I always tend to draw on the XY plane, and I've already started by drawing a 3/16 diameter circle that is going to be for where the axle goes through. Now, the pear cam is this one right here. It's named that because it's shaped like a pear, and you'll notice that there are different values that are given in equation form. So in this case, the top one says that it has a radius of 1/4 d. In this case, when we're looking at d, d is referring to the nominal diameter of the cam. Now, each one of you will have a different nominal diameter, so you're working in your rows, so teams of 4. So one person will do 1.5, another one will do 2, 2.5, or 3. So each one of you will have a different value. So for the first thing, we're actually just going to draw a couple of circles. So I'm drawing 2 circles that are aligned vertically with the center point. You notice the bigger bottom circle is also concentric with my axle circle. I'm also going to use my vertical constraint to make sure that they stay lined up. And then I'm going to draw a line that is connecting the top circle and the bottom circle. I want to make sure that that line is tangent to the circles. And if I get that it already exists, that's good, because I want to make sure that they are lined up. And then I'm going to measure, I'm going to actually dimension my value. Now, you'll notice with this that I've already used a fraction. You can use fractions in Inventor. It will actually do math. So this bottom circle, if we look here, says it has a radius of 1/2 d. So I'm going to use the 1.5 inch nominal diameter as an example, but you'll substitute whatever your value is for d. So here I'm going to do 1/2 times d. In this case, d was 1.5. I could also do 1.5 divided by 2. That's the same thing. It's just a different way to write it. So 1.5 times 1/2 is the same thing as 1.5 divided by 2. Whichever way you're comfortable with is up to you, but you'll notice you're able to actually write it as an equation in there. When I hit enter, it calculates that value for me. Now my top one is 1/4 times 1.5. So again, I could write 1/4 times 1.5, or I could do 1.5 divided by 4. Either way, that allows me to do that. And the distance between the center point of the top arc and the center point of the bottom arc is the same. In this case, it's also 1/2 d, so it's the same as this value. So I'm just going to click on this dimension already, since I've already measured that. Inventor has a way of being able to refer to other dimensions, and as if I were to change this one, that means this one would automatically change as well. I'm going to finish my sketch now, and it says that the thickness of the material is 3/16 thick. So I'm going to extrude it 3/16 of an inch. And that is how you make a PearCam.